All right, so first things first, how do we find the inverse for this first guy here? What do we do for this guy? Did that on like Tuesday of last week. How do we find the inverse? Say it again. Flip the variables. I needed to find my x and my y and switch them. Yep. So first thing I'm going to do is I'm going to take the fact that this is in my function notation and be like, we needed to have a y so we can switch them. So I'm going to switch my function notation back to our algebraic notation. 2x plus 6. We find our x, we find our y, and we make them change places. So this is the step that creates the inverse. It's technically the inverse over here when we write it as our x equals to y plus 6. But we can't do anything with that. We can't write it in function notation, and it's really, really bad math grammar. So we need to fix it. What do we need to do to be able to fix this? Aside from not rip the pop socket off the back of the iPad. There we go. What do we do?
Get y by itself.
We want the y by itself because we don't write x equals equations in math. Oh, gross. That's very rare for us. So what do we do to get that y by itself? This guy's the goal. What are we going to do to get this y all by itself? We will eventually. I'm going to go ahead. Let's not start with dividing, but we will. That'll be our next one, okay? So let's subtract the 6 first. It's not wrong to divide first. It's just going to give you a higher odds of more fractions early on. In this case, it would give you the exact same number of fractions, but just kind of as a habit, I like for us to do our subtraction first. It's not wrong if you do the division first. It's just going to be harder. So we've got our x minus 6 equals our 2y, and we're still looking to get that y by itself. Now what are we going to do, Raymond? Now we're going to divide by 2. Excellent job. Divide by the 2 here, which means this guy divides by 2 and this guy divides by 2. Everybody gets divided by 2. Because then that 2 and that 2 cancel out. Huzzah, our y is by itself. That's what we wanted. That was the goal. We wanted a y equals. We can write this as our x over 2, and you can leave it like that. You can put it as 1x over 2. You can put it like that. You can put it as 1/2 x. Either way, any of those options are fine. And then we also have our 6 over 2. 6 over 2 simplifies down to be what? 3. So our inverse, we're going to put it back in our function notation where we made our f, but we took it and we flipped it on its head. So it is the inverse of f of x. And you can write it exactly like we did here. You can put it as our 1/2 x minus 3. That is also okay. You can put it as x over 2 minus 3. I was going to say you could even put it as our x minus 6 all over 2. That's totally fine. They are all equivalent fractions. But we do want to put it back into our function notation when we're given a function notation. So we want to put it back. Questions on anyone? Okay, then we went old school geometry for our other bell work problem. Because we do have SATs coming up in a couple of weeks. On the 6th of March. Which is in like 2 weeks.
Why isn't the SATs?
Uh-huh.
Why isn't that being talked about? That's next week.
Yeah, next Thursday? Wednesday? Thursday? Somewhere around there.
6th?
Yeah.
Oh, that's right. It says not like you mean it. I did not even hear that. Don't you gotta knock like you mean it. Thank you.
Yeah, SATs are in the 6th. That's why we're doing so many of these SAT practice problems. And why we're seeing really, really random, really, really old math review coming up. It feels really chaotic, but it's because we're pulling those all from the SAT practice banks, trying to help you guys remember some of the older things. Like Pythagorean theorem! Woohoo! So what the heck do we do with this? Who remembers?
So because you already have the hypotenuse, which is C,
Mm-hmm.
you would do C minus A
Yeah.
equals B squared.
So I know this guy's C because he's the hypotenuse. Because it's the longest one. It's the one that's not touching the right angle. However it is you choose to remember that guy. That's our hypotenuse. So we know he goes in C. As far as which one's A and which one's B of the legs, it really doesn't matter. We can call this guy A. We can call the X the B. But it really, really, really doesn't matter. I could just as easily switch those. So now that we have those guys kind of named, what we're going to do is substitute them in. So we're going to have our 4 squared plus something squared. Might be X, might be B. You can leave it as the B if you want to. Equals our C, which was 5 squared. And you can absolutely do it the way that you were saying, where we get our 5 squared and we subtract the 4 squared and you move them around like this. Totally fine. I'm going to simplify them before I do any of the operations on them, mostly because I don't want to have to try and remember what things are squared and what things have already dealt with squares. So our 4 squared, what is 4 squared? 16. This X squared we haven't done anything with, so I'm just going to leave him. And then what is 5 squared? I heard it was 25. So what do we do to get the X squared by itself? Ooh. Minus the 16. And we get that X squared equals 9. So what does X equal? I was going to say, what did you say first? Yeah. I was going to say, because what we're doing is we're square rooting both sides. Normally when we square root both sides, we will put on the plus or minus for our 3. But can I have the length of a triangle be negative? No. I can't measure a negative side. Whether I go, it's kind of like steps. If I take 3 steps that way or 3 steps that way, don't matter. I'm still taking 3 steps. I'm not taking negative 3 steps. So the X on this one is going to be 3. It's too close together. It's getting all smudgy. There we go. Okay, so Pythagorean theorem is one of those things that they love to pull out on things like standardized tests because it's showy and everybody knows it. It's one of those things. It's like saying y equals mx plus b. A squared plus b squared equals c squared. Everyone's seen it at least once. If nothing else, in the Lego Batman movie. It made me giggle so hard when it was in the Lego Batman movie. He physicalizes it outside the Fortress of Solitude. He acts it out. It's fantastic. If I taught geometry, I would get that clip and play that then for years. I had small children when the Lego Batman movie came out. So, like, we were at the prime age for that. Questions on our bell work before we do our SAT prep question, because that was not it. It was just something we tied in. Oh, snap. Surprise. Okay, so here's our extra practice for SAT stuff. We've got a graph that's shown. That's a graph that you don't know how to draw yet. Previews. The last chapter of the year is when we're going to make those. Do not worry, I shall get you there. But we can still look at our graph and we can still evaluate it. They want us to know, or to find out, what is the value of f of 0. So this is our graph of f of x. So what are they asking us to find out when what is 0? What did they change between my f of x and f of 0? What's different between this and this?
Nothing.
F of x and f of 0? What's different?
To 0.
Yeah, the x turned into a 0. So what happens when x equals 0? Where is that? This is my x-axis, right? Here's my x is 0. So what is the value of my graph when x is 0? 3. X is 0 is right here, so we're looking up this way. There's my line. So which of these options are going to be our answer? D. So whether we know what this shape looks like, what it's called, where it came from, or anything else about it, I can still figure out what happens when x is 0. So we just need to be really careful on that, okay? They will, I can almost guarantee you they will do some sort of function notation asking you just like this. There are so many in the practice bank where they just give you find f of 0, find f of 2, find f of -3. On these kinds of questions where they give you a graph and they just say find. And they have it in function notation. So there's a bunch of those in the practice bank. So that means they're probably going to be on the SAT. I would bet money there's going to be at least one like that. Maybe not with this particular shape graph, but I would based on the sheer number that are in the practice bank, I would bet there's going to be at least one graph where they say find f of something. Okay, so make sure we're paying attention to these kinds of things. They're going to show up again. So we're going to go on to our very last bit of this chapter, which is going to be talking about the very back side of homework 6.2, which is where we're going to verify if functions are inverses. Oh my God, I got my 12 emails already this morning. My watch is just buzzing like crazy. So again, we don't really need to have this paragraph up here. This is what the book says. I like to try and use the textbook because, we paid no much money for it, but, using the things. The important piece up here is the way we can verify if functions are inverses. This is where we're going to take what we did Monday, Tuesday last week and combine it together with what we did Wednesday, Thursday, Friday last week, where they felt very, very separate. And the way we can test if things are inverses is if, when we do our composition, like f of g of x, so these kinds of guys, if we can do the f of g of x, and it simplifies down to be x, and, so we have to do both, g of f of x also equals x. So both have to be true for them to be inverses. It only takes one to not work for it to be able to, us to be able to say that they're not inverses. So we need to do both compositions. So we need both to say yes. It only takes one to be wrong for us to say no. So we're going to take and do f of g of x, where I substitute g of x into my f of x, and we're going to do g of f of x. Bless you. So, what's up? Oh, yeah, give me a second. What's up? They both have to equal x. Just x and only x. Not 1/2 x, not negative x, not x plus 2, not 7x minus 4. X, just the x and only the x. Yes.
It totally works too.
It does. I was so excited to find that. It was so cool. I know. It was only like $5. I had to. I'm a grown up and I get to make grown up money choices. So ha 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 ha. And I choose to spend 6 of my dollars on the aggressive giant pencil. Maybe people will stop stealing my pencils. All right. two functions, and we're going to do these compositions to see if they're functions versus if they're inverses or if they're not inverses. So this is how we test it. So here's our first set. We're going to start with, they're going to give us a problem like this. It says, are they inverses? Or prove if they are inverses. Or verify if they are inverses. All of those things mean the same thing. Does it work? What we're not going to do is just straight up find the inverse. We are supposed to use our composition to test. So we are going to do our f of g of x. So I'll do f of x in green, and I'll do g of x in purple. So we're going to do both f of g of x, and we're going to do g of f of x. So it's a good chance to remember our composition as well. So let's start with the left one, f of g of x. So what are we going to do? What are we going to write for this? How do we do f of g of x? So we need to take our g of x function. I know g of x equals this guy. And we need to substitute it in place of the x here. In place of, not next to. So we need to take our 2 times something. But the something, instead of being an x, is going to be what g of x is. Our 1/2 x. I'm going to get rid of that out of the way just so we can see stuff. So this is our f of g of x. We need to simplify it down. What is 2 times 1/2 x? What is 2 times 1/2? Y'all can use calculators. 2 times 1/2.
One.
1 x. So our composition here on our f of g of x equals 1x, which is the same thing as if it equals x. So we have a really good odds that these are inverses, but we have to do the other side as well to be able to say for sure these are inverses. So we're going to do the same kind of thing just in the other direction. So now we're going to take our g of x and we're going to substitute in our f of x in place of the x. We're substituting it in this way now. So our g of x is our 1/2 times something. And what our substitution is, what we're subbing in, is our 2x, our f of x. What do we get when we simplify this side? What is 1/2 times 2? 1. So we get 1x. Which is the same thing as if we got x. So f of g of x equals x, and g of f of x equals x. So what we can say, and how we say that this proves it, is since both compositions, which I will write it when I sit back down, because if I try and write while talking and walking, it's going to be a mess. Since both compositions equal x, these are inverses. That would be the technical way of saying it. Since both compositions, you can also say since f of g of x and g of f of x, it means the same thing. It's as saying both compositions equal x. They are inverses. So that's how we prove that they are or are not inverses. Since both compositions equal x, they're inverses. And it has to be both for sure to be able to say that they are. Questions on this first one? We're going to do a couple more. So here's our next one we're going to do. Are they inverses? Means we are going to do our composition to test it. So we need to do our f of g of x and our g of f of x. So now I'm going to do this. I'm going to do f of x in blue. And I'm going to do g of x in green. Because I can. Why not? So we're going to do our f of g of x. And we're going to do our g of f of x. So in order to see if they're inverses, we're going to test both. So this is when we're taking our g of x. We're going to take this equation, and we are going to substitute it in place of the x here. It's going to go inside. So my f of x is 6 times something minus 2. But that something it's being multiplied by is actually our 1/6 x plus 3. So we're substituting it in. What do we need to do on this one to be able to simplify it? What the heck do we do next here? Distribute. I need to distribute this 6 here and here. So when we do that, we have 6 times 1/6 x. What is 6 times 1/6 x? Just our 1x. Like that. 6 times plus 3. 18. So we have a positive 18. And then we have a minus 2. What does this simplify down to be? X plus 16. Is that the exact same thing as having x? Is x plus 16 the same thing as x? So we can tell right here, these are not inverses. Because our f of g of x does not equal x. It has to equal x, just the x and only the x. We're going to practice the other side just to see that side too, just so we can practice our composition again. But 1 is enough to tell us this is not the same thing as x. This is x plus 16. It's similar, very similar vibe, but it's not exactly the same. So let's do the one on the right as well, just to kind of practice our setting it up, seeing what it's going to look like. Once we have one that disproves it, we don't have to do the other one, but I want us to practice our composition again. So if I take our f of x and we substitute it into our g of x, I'm going to take my 1/6 times something plus 3, and we are taking our 6x minus 2 and substituting it in place of this x. So we're going to have our 1/6 times our 6x plus 2. Substituting those pieces in. Plus because it's, oh, no, plus because I didn't actually see. Minus because it should exactly match. From this angle, it's all very blurry. Because I could write from any angle. It's just when I have it zoomed in so my handwriting doesn't look, I can't actually see the other equation. Because then my handwriting's not tiny. Because if I write back here, I have to write really big. So what do we do over here? Dramatic. Dramatic. Distribute. Exactly the same. So we're going to distribute this guy. When we take our 1/6 times our 6x, we again get a 1x. We like that. Gives us hope. 1/6 times minus 2. What's that? Yeah, negative 2/6, negative 1/3. Either way, unpleasant.
Would you prefer to
Genuinely does not matter. It's the 2/6 is the exact same thing. They are equivalent. 1/3 is just simplified. Either way, does this equal x? I could type that in the calculator, my minus 1/3 plus 3. We totally can do that. We can also here go, that's clearly not going to cancel out. This does not equal x.
So it should immediately equal x.
When it's fully simplified down, it should equal x. Just the x, only the x. So these guys were inverses because they got down to just x. These guys are not inverses because neither one of them got down to x. You have to have both for it to be inverses. One will tell us it's not. Let's practice it again. So another one. This one's a little fractiony and icky. But we can do this. We can do this, especially because, you know, we can use calculators. And the yellow calculators, which they're in the back. I just cleaned them off on Friday. They will let you type fractions that look like fractions, and we love that.
Ew.
I know, it's fractiony and gross, but we have calculators, and we can do this because we are awesome. So I'm going to do my f of x in the purple. And I'm going to do my g of x in the blue. I'm just making my blue a little bit different. So it's unpleasant and fractiony, but we can do this. I promise. So we're going to set it up the same way. We're going to do our f of g of x. So wherever I have an x in here, we want to substitute in our g of x. This guy is going to go in place of that x. So we can write this as our 9x plus 12 over 9 plus 4/3. Gross. But we can do this. Because what can we do to try and simplify this fraction thing? Ugh.
Multiply by 1? Wait, no.
I was like, we'd have to do that to both sides of the equation, which means we'd then have to just divide back anyway. So that's not going to be quite the plan we want.
So divide.
Yeah. Think of it like when we were dealing with monomials, we'd cut it apart at the plus sign. Cut it apart. Make separate fractions. So we have 9x over 9 plus 12 over 9 plus 4/3. Treat these just like monomial division where you cut them apart. Oh, snap. Relevance. So we get 9x divided by 9, which is the same thing as just x. 12 divided by 9, which is the same thing as 4/3, because they both divide by 3, plus 4/3. What do we get when we simplify that? What's 4/3 plus 4/3?
I did not mean to press that button.
It'd be 8/3. They already have common denominators, so it's just 4 plus 4. Yeah. So are these inverses? Nope. Because f of g of x does not equal x. That counts as justification. If we say y, that's why. That's how we know. So we don't have to do the other direction. You can, And if you look at those and you go, ew, I'd really rather not put a fraction or put that equation into the fraction, you could absolutely have gone the other way and done your g of f of x first. It still would not work. But you don't have to do both if we know for sure it's not. We only have to do both if we're saying, I think this is. We need to show both ways. Okay. Let's do one more. Ickiest of the day. Because we're not always going to give you lines. Oh. We're okay. We can do this, I promise. You've worked with these before. I know. Told you, this is the last one though. It's the last one. So we've got f of x is the square root of x plus 13. Which I'm going to do f of x in my purple. And g of x is the quantity x minus 13 squared. So let's start by doing our f of g of x. So we're going to substitute in our g of x, bless you, in place of the x. So we're going to take this whole chunker, this whole guy right here, and we are going to put it in place of the x. So this whole chunk is going to go under the radical. So we have the square root of that thing, our x minus 13, making sure, squared. And then we have outside our radical a plus 13. So setting it up just like this, that looks like a B. There we go. What the heck happens next?
Well, since it's
The square and the square root cancel each other out. My square root and my square cancel out. So right now what we have is x minus 13 plus 13.
I was putting pluses.
As I say, watch out for signs. Signs are super duper important. So what does our f of g of x simplify down to be? It's like, because we got x minus 13 plus 13, so we have x plus 0, or just x. Oh, well, now we think there might be inverses, so I guess we have to do the other side too. What's now? Look at me being mean. So since we think they might be inverses because I got f of g of x equaling x, let's test the other side too. Let's do our g of f of x. Same kind of vibe. Now we're just going to take our f of x, this whole guy, and put it in place of the x. What's up?
I set it up. It looks so weird.
Square root of x plus 13 minus 13 squared. What do we do first?
Square root two? Do they cancel out this time? Or does the parentheses block it?
I was like, we gotta look at the parentheses first.
What do you do first?
As I say, can we simplify inside our parentheses? What is 13 minus 13? 0. So what we get when 13 minus 13 is 0 is we get square root of x squared. Because square root of x plus 0 is the same thing as square root of x. So now what happens? The square root and the square cancel out now. So we're left with just x. So are these inverses? Yeah. Because both of our compositions, our f of g of x and our g of f of x, both equal x. So the other way of writing that is, since f of g of x equals x, And I'm going to do the other notation just so we can see both. Our g of f of x equals x. They are inverses. How much worse my handwriting gets when I zoom out too far. Okay, so we're using that composition to do that test. That's what we should be doing on the back of 6B2, that second homework. Okay, using our composition, we're substituting them in and simplifying. Okay, questions on, or on any of the ones we did together today? Because that is actually everything for us and for the chapter. So, couple little notes for us. We have another SAT practice Canvas homework. It's on Canvas. It is multiple choice. You're not seeing them? Okay. I will pull it up here in just a second. I am also, I'll pull it up and show you guys where it is on there just so I can see it and see where things are going wrong. I'm also going to pass out the chapter review for you guys because we have a quiz coming up on, not Friday. That is definitely the wrong day. It's coming up on Wednesday. Oh, that's at February, not Friday. My brain switched that to February, Friday. Like, no, February 26th. That is the correct date. I was like, but my brain saw February and went
What's
Friday.
the second dot? I thought why did you put another dot?
Because I was going to put you on there, so it's going to finish the lot. I have the piece reviews for you guys. I'm going to get everything posted up on the Canvas page today. All the answers, all the everything. Because I'm actually not going to be here tomorrow. So, I will get everything posted up today. If you guys have questions on stuff tomorrow, please feel free to send me messages. I'm going to be out at a training, but I will have access to my computer and my phone. So feel free to send me messages. I'm not going to respond during class time because honestly it's right when I'm eating first. But I will get back to you as quickly as I can. So here's our chapter review.
Is tomorrow a birthday?
Yes. Okay. Also, because I won't be here. So, let me switch to here so I can show you where things are on this Canvas. Huh? Oh, you found it? Okay. Let's say, but you're not the only person I've seen have that issue. Oh, it won't remember. I'll search over here. So the Canvas assignment, when you sign in on Canvas, it should show up in your to-do list.
Are we still able to do the one from last week?
Yes, you should be able to. So it should show up, and normally we have like a to-do list over here, just because I have to teach you things lined up with slightly different settings. So if I come in here, so it's your page, it should show up over here. Or if you can't find it there, you can click on this week's button, or this month chapter button, which we have our lovely name, which is very relevant for our composition. Oh snap. Down here we've got last week's SAT practice assignment, this week's SAT practice assignment, and then today I'll come here and put in our answer keys on these two pieces and for our review. Okay?
Can I change you?
Please. Okay, so that's where all of those pieces are. I'm going to put our announcements up on the board, and then that's kind of it for this chapter. The notes and videos should all be posted on the Canvas. But what you're going to do with those is you're going to just take the syllabus solution. So then, f plus g just means we're going to take our f of x plus our g of x. Substitute it and simplify. Same thing with the subtract and find the divide. With the divide, we're just going to set it up kind of as a fraction where we have our f of x over g of x. We're going to
say that wherever that U of X is can equal 0, and that's going to be.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
And then it's an,
Oh, take, the number of points is 24 days.
Good morning, Red Devils. Today is Monday, February 24th. I'm Alana, and I'm the Pike Robo Devils robotics team has their first robotics competition on March 14th through the
it's
16th.
funny.
The team will meet in D144 on February 26th.